In this video, we are going to connect an SLC 504 PLC processor to the personal computer, set up communications, learn how to download, and write a very simple program. This process uses two different software packages. Both are Rockwell software. If you go into All Programs and Rockwell Software, first one we're going to open is RS Links. Gives us a choice. We're going to click RS Links Classic. This is nothing but the communication software. All this does is let the PC communicate with the PLC. You'll hear me use those terms a lot. I'll try not to go over them too quickly. Obviously, when I say PC, I mean personal computer. PLC is our programmable logic controller, which is a SLC 504. You'll notice this software has several different drivers in it. Depending on what different devices this PC has communicated with, it will have several different drivers. You should already have a driver called ABDF1 DH485 or something like that. It might say ABDF2. This says it's using data highway, which is a Rockwell communication structure, with an RS485, which is the type of connector. Newer SLCs can use Ethernet. For this process, we're going to use data highway, RS485, and it's a serial connection. You should already have a cord connected into the PC with one end in the USB slot of the PC and the other end in the RS485 or the 9-pin connector already plugged in to your SLC 504. When you open this software and go to Communications and RS-WHO, that goes out and it looks for anything that's on the network. Now, I didn't click a specific network, so right now you can see that my SLC 504 is communicating with my computer. Now, you can't see it, obviously, but I'm going to turn off the power to the SLC, and you'll see a red X. That red X just means that the computer knows there should be a processor out there, but it can't see it. It can't communicate with it. And there could be several reasons for that. The PLC not having power is only one of the reasons. I'm going to connect the power back up. Our little red X should go away. One thing to note, Rockwell software is kind of clunky and kind of slow, but it is by far the vast majority of industries use Rockwell software. Our RS Links software, it's now seeing our processor. If it had power and had that red X or was not communicating for some other reason, I'm just going to show you. You shouldn't have to configure a driver, but I just want to show you the process. When you click Configure Driver, these are those four different drivers that we saw earlier, and one of them is DF1 485. You won't need to do this, but I'm going to delete it. And put it back in. So right now, that communication channel isn't even available to the PC. These processors are some processors on the Ethernet that it's expecting to see but doesn't see them. Those don't concern us at this point. I'm going to add new. I'm going to go to RS232 DF1, even though it says 485. RS232 and RS485 can be interfaced together. Add new. This is where it comes up and says ABDF1. You can give it a unique name, but you don't need to because generally we're only going to have one serial driver. The device is a SLC, so I have to choose that. I already know that this particular USB port is showing up in my PC as COM port 12. You're not going to know that. The instructor can help you get that figured out if you were to need to do that. And then we just hit auto configure, and it sends some signals in, and if it sees them back, it knows it's communicating. And then it says auto configuration successful. So I should be good to go here with my driver. I'm going to go, I'm just going to click it, make it blue so I can read it well. ABDF1 says it's running. I'm not going to hit the red X, I'm going to hit close. Probably doesn't matter. Now when I open up my ABDF1, I can see my SLC 504, and we know we're communicating with it. I'm going to just minimize this software. Minimize it or close it, probably doesn't matter. I'm kind of superstitious with Rockwell. I do certain things. Whether or not they really make a difference, they seem to. So now I know that my computer should be able to see my PLC. So now I'm going to open up RS Logix 500. I'm going to go into Rockwell Software, RS Logix 500 English, and then you just pick the software icon there, and it's going to open up. I like to maximize the screen so I can get a good feel for what it's doing. This is just the programming blank palette, if you will. So we're going to open a new file, a new program, and we need to select our processor. Well, I happen to know that this is a 504, so you can see the types here. This particular one, yours should be similar to this, an L542 revision B. So this should be it. If you're close, if you've got the right processor, but say you see the different memory sizes, if the memory size is not correct, when you go to download the program, the software will actually notify you, and you can just select the correct memory and continue on. You'll notice here is my driver. This could show up blank or with some different drivers in here, but this is our communication setting, and it is in there. The very first time this will be blank, and you have to select it, but I'm just going to hit OK here, and we get a blank program. We're not connected to the PLC. We don't need a PLC to even do the first steps of writing a program. Over on the left, we have a file window. When you're over here, you can see the layout of the software and the different parts of the processor that it sends and receives data to and from. We'll get into a few of these files as we go through the course. You'll notice up at the top here, we have this little window with the ladder, because these are ladder programs, and nothing's moving. When we get this connected up and we're talking to the processor, we'll see this moving, and we'll actually be able to know that we are connected and we're online with our PLC. The first thing we're going to do is download a blank program with nothing on it just to verify that it's working. But the first thing we need to do is set up our I/O configuration, our input and output configuration. Because we could have any variety of input and output cards, our program, the software, needs to know what's at the other end. We do have a 4-slot rack. I'm just going to hit Read I/O Config, and I get this window. Again, it wants to make sure it has my driver. If the wrong driver or no driver were in this window, it wouldn't be able to connect. And I'm going to hit Read I/O Config. We're not online with the processor, but the program is going to go out, use that established communication link, and actually see what the processor has for I/O cards, and it's going to populate our list. So I'm going to click Read I/O Config, and this is what I have on this PLC. You can't see it in front of me, but it has 2 input cards and 1 output card. Pretty similar to what you have in front of you. It's not going to be the exact same configuration. Now my I/O is configured, so I can close that window. And now I'm just going to download. This is just a blank program. It has no instructions. It doesn't do anything, but I'm going to go ahead and download it. This is a test that I will often do just to verify that your communication path is correct. I'm just going to call it Monday Setup. You can leave it in the My Documents. It's going to save it under Rockwell, your name. It should come up anytime you need it if you save it to the default location. If you don't give it a name, you'll have a lot of files with the title Untitled 1, Untitled 2. Gets kind of monotonous. So it's saving the program. It's going out. It's looking for that communication process. It's saying it's found something. Are you sure you want to download? The reason it asks you this is if this processor were functioning, if we were in a factory and it was printing money or whatever our factory is doing, when you download a new program, even if it's the same program or a similar program that only has a modification, when you download, you completely stop the processor and then enter the new program. So operation will stop. In the classroom, obviously, we can download all we want. We don't have to worry about it. In the field, there are times where you will not want to download because you would shut down the big money-making process and make a lot of people mad. My key switch, again, you can't see it, but my key switch is in remote. It's in the center. That means I can change from program mode to run mode without turning the key switch on the processor. And it says the processor is currently in run mode. Would you like to switch to program mode? Well, I have to in order to download my blank program here. And as I mentioned, Rockwell software is not super fast. You might want to have your favorite diet beverage while you're waiting for your program to download. The bigger the program, the longer it takes. However, with Ethernet, they'll download very fast. One of my sayings is Rockwell software has been killing flies with sledgehammers since 1959. Their software is just so big, but they do that on purpose because they want their software to be able to work for any possible situation that a customer might need. So my program has downloaded. It's asking if I want to go to run mode. Yes. Up here on the left is an indicator. Right now I'm offline. It's asking if I want to go online. And I'm going to click yes. And right now it says remote run. And sometimes when you download, it may come up in remote program. Are you sure you want to change to program? And it'll turn blue. There are certain changes that can only be made in program mode. So sometimes it's handy to switch to program mode and then go back to run mode. Generally, we're going to just go offline, change our program, and re-download the program. I am now in remote run. I have a blank program in my processor. It's not doing anything. However, we'll get into this a little more in a later lesson. But if I open my input file, you'll see I have a 1 here at bit 0. I have a selector switch on bits 0 and 1. I just flipped the selector switch and you'll see that the 1 moved to bit 1 in the program. I just switched it back and now the 1 goes back to bit 0. So I can verify that I have inputs going in and out of my program. I'm also going to open the output file. Now again, you won't be able to see this, but when I enter a 1, you might have faintly heard the click. A light turned on that's connected to that output. I'll hit 0 and turn it off. But by doing this, you can verify that your inputs are correct, your program is communicating with the PLC, and that the communications are working. As I mentioned, this program isn't doing anything. So I'm going to go offline. I'm going to write one simple line of logic just so that we can get comfortable transferring the program. Save the changes, sure. You can add a note if you want, you don't have to. This is just saying that those data tables that I opened up, those have changed, they're not the same. It's going to save them the way it sees them. And it's asking, is that okay? Sure, that's fine. So once this goes offline, it's verifying the image in the processor, and the image is the I/O configuration, the communication channel that we've set up, some of the other housekeeping things inside the program, the controller properties, these things over here. These are part of the image. It's resaving those, it's updating those in case we had changed something. So now I'm offline with my blank program. I'm just going to add one new rung. This is called the instruction palette up here. We have some simple instructions, and we can get into some more complicated ones that will go as we go through the program. When we get into programmable automation controllers, we'll use some of these other ones. For now, this user palette generally has most of the ones that we want. The first one here on the left is to add a rung. There are a couple ways that you can do this. I can click on it and drag it down, and it puts a new rung in. Or I can double click on it, but then I usually get two. I don't know why, but however you do it, I only need one. In order, you see it has little E's. That means this rung needs to be edited. It hasn't been verified and downloaded. My cursor, the red highlight, is on the bottom rung, which you can see is the end rung. There can never be any instructions on that last rung. The processor needs to see that to know it's at the end of the program. So I can't put anything in. I have to highlight the rung that I want my instruction entered. And I'm going to enter an examine on. They're used a lot. And then I'm going to add an output. Now I need to give these two instructions addresses so that they know what they're going to correspond to. So when I go into my examine on instruction, if I just press I for input, I get the word input, and I'll double click that, or I'll hit enter, and it's showing me my two input cards that I have, and the one that we looked at before was the first one. So I'm going to click that, and if I double click that, I get that first bit, which is bit 0, which I know works. I've already tested it with my selector switch, so that bit is perfectly fine. I'm going to hit enter, and you do want to put a name in these. We won't sign off your labs if you don't have names on your instructions. I'm not going to sit there and try and guess which button is bit 7 and which button is bit 13. So I'm going to call this selector switch left. I'm sorry, right. Of course, you can't see it. You don't care what I call it. Selector switch right position. And I'm going to hit OK. And you'll see my label comes up here. I'm going to go to my output. And I'm going to press O for output. Highlight the word output. Hit enter. And I only have one output card. So it's going to bring up that first bit. I know that bit 0 is the light that you couldn't see, but for a simple demonstration, this will be fine. Hit enter, and I'm just going to say green light. Your bits are going to be a little different, but we will show you where to address those. We're only doing 2 bits, an input and an output bit, so it shouldn't be very hard to establish those. I am going to make it a little more complicated. I'm going to add one more rung. And I'm going to add an examine off bit. We're going to talk about both of these a lot. And I'm going to use a different output. But I'm going to use the same input. I'm going to select enter input. Hit enter, When I select my input card, the next available bit comes up, bit 1, but I want the same bit. I want bit 0. So I'm just going to type it right in there. And because this label is tied to bit 0, it's going to come up. And it looks like I have the same instruction, but I don't. I have the same bit, but two different instructions. And this one I'll make a different light. I'll just select whatever output it has for me. Bit 1. Bit 1 is an orange light. That's fine. But this is going to let you see how these two instructions work. My program's written. I can download it, but before I download it, I want to make sure that there's no errors. I want to compile it. Compile is a programming term that's used to check the syntax. It makes sure that the instructions that you've used are used correctly. It's not going to check that your program works because the software doesn't know what you want it to do. It's just going to make sure that any instructions you do use are addressed correctly and in the correct form for that instruction. So to check that, you can check the project or just the file. I usually verify the whole project, even if I only have one file. And the little blue thing came up. You'll notice down on the left, way down here, it says verify has completed, no errors found. If there had been errors, I would have got a little window here and I could have opened it up, and it might have said in rung 1, instruction 1, say I didn't put an address in it at all, well, that would be an error. It has to have some type of address. So I've got my simple program. I'm going to go ahead and download it. It's just asking if I want to download. Yes. It's in run mode. Do you want to move to program? Yes. It's asking me to go back to run mode. You might have heard the click in the background. That was my processor. Do you want to go online? Now, when I went to run mode, the processor was working, but I couldn't see it on the computer screen. The PLC does not need the computer. Right now, this computer is running, and I could unplug the computer, and the PLC is going to run fine all by itself. That's usually the way they work out in industry, is they don't have a PC plugged into it all the time, only when they need to monitor something. So I've got my two rungs. My first instruction is an examine on instruction. The green around it means it's true. This rung goes to the other end, and this green around this here means that my green light output is lit, and I can verify for you that the green light is now lit. Now you'll notice, while this examine off instruction has the same bit, the instruction is not true and the output is not true. If I go to my input file we looked at, bit 0 is a 1. Well, we'll talk about this more, but these instructions are doing exactly what they're supposed to do. An examine on instruction says if its bit is a 1, it's true. And it is. If this bit were a 0, it would be false. An examine off instruction says if this bit is a 1, it's false. And this instruction is false, so this output is not on. When I flip my selector switch, bit 0 now became false. It's a 0. I know the zeros and ones get kind of crazy, but bit 0 is now a 0. Bit 0 was a 1. So this bit being a 0, the examine on instruction says a 0 is false. So this output is not true. And the examine off instruction says a 0 makes it true. And now I can verify for you that the orange light is lit. And by going back and forth between these two positions, these two different instructions, manipulate these outputs. As you do this lab, you'll notice my little window here, the ladder is spinning, showing that I'm communicating, I'm online, I don't have any faults. And we will add to our programs as we get into these different labs. When you have this lab completed, it'll look a lot like this. Again, your bits numbers might be different, but have your lab signed off and you'll be ready to move on to the next section. Thank you.